Here's the answers for the 6.1 practice. Okay, so question number 1. From a large group of people who signed a card saying they intended to quit smoking, a random sample of 1,000 people were selected. It turned out that 210, or 21%, of the sampled individuals had not smoked over the last 6 months. So our population, or all who signed the card, our sample would be 1,000 people. Our statistic from that sample we collected was a p-hat, okay, 210 out of 1,000, of 0.21, 21%. So a sample p-hat would be 21%, representing the true proportion. Okay, so our p, true proportion of those who have not smoked within all who signed the card. Okay, part B. The pediatrician wants to know the 75th percentile for the distribution of heights of 10-year-old boys. So she selects a sample of 50 10-year-old boys. That the 75th percentile is 56 inches. So our population are all 10-year-old boys. The sample were the 50 that were sampled. Of the 50 that were sampled, the 75th percentile, or quartile 3, was 56, which we want that number to represent from our population the parameter of the true 75th percentile, or quartile 3. Okay, next one. A production of ball bearings is supposed to have a mean diameter of 2.5 centimeters, and an inspector chooses a random sample of 100 bearings from the container and calculates the mean diameter to be 2.5009. Okay, so it's not quite what's intended, but it's only a sample. Okay, so our population are all the bearings. Our sample would be the 100 that were selected. The statistic, so the average of these 100 bearings, right? So that's an x bar, is equal to 2.5009. And we want that to estimate the true mean of the diameter, which we believe to be 2.5000. Part B. During the winter months, Mrs. Starnes set the thermometer at 50 degrees to prevent the pipes from freezing in her cabin. She wants to know how low the interior temperature gets. A digital thermometer records the indoor temperature at 20 randomly chosen times throughout the day, and the minimum reading is 38 degrees Fahrenheit. So our population is the true reading inside the cabin, and the sample was, we collected 20 different readings. Of those 20 readings, the minimum was 38. We want that to represent the true population of all the readings, true minimum temperature within the cabin. Okay, question number 3. We have 2 male students and 3 female students. So Abigail had a score of 10, Bobby 5, Carlos 10, Deanna 7, and Emily 9. So list all 10 possible simple random samples of size 2. So of size 2, we could have, think about these scores here, right? We could have 5 and 10. We could have, okay, so these are all the scores. So we could have the 10 and the 5, the 10 and the 10, the 10 and the 7, the 10 and the 9. We could have the 5 and the 10, the 5 and the 7, the 5 and the 9. We could have the 10 and the 7, the 10 and the 9, or the 7 and the 9. Okay? Now, it wants us to find the mean score of a size 2. So the mean of these two would be 7.5. The mean of these two would be 10. The mean of these two would be 8.5. This would be 9.5. Okay? And if you find the mean of all these scores, this is our approximate sampling distribution. So display the sampling distribution of the sample mean. Okay? So there's our dot plot for number 3. Okay, number 4, who did their homework? So a new school newspaper, they claim that 60% of the students at a large school completed their homework assignment last week. Some statistics students went to investigate if the claim is true. So they chose 100 students from the school to interview. They found only 45 of the 100 people, so they found 45%. So they claim that it's 60%, but they only had, in their sample that collected was 45%. They suspect that the proportion of all students who completed their assignment last week is less than. So based upon their 45%, they believe it's less than the 60% claimed by the newspaper. So determine, okay, so they took, let's say it is 6%. So notice here, they did a bunch of different selections of 100 people. Okay, so if the P is really 0.6, they took a sample of 100 people in a population where it's 60. Okay, and they got these different answers. So each of these dots represents one of these surveys that they did. Okay, so they did a survey of 100 people, they got 59%. They did another survey of 100 people, they got 73%. Did a survey of another 100 people, they got 55%. Okay, so there's a whole bunch of them here. There's 250 of them, of these samples here. Okay, so at this one right here, that means, what does that dot represent? That dot is one sample of 100 students where 73% of the students did their homework. Okay. Would it be surprising to get a simple random sample of 0.45? Okay, so this, if it really is 60%, is 0.45 very probable of happening? Did it happen at all? No. It would be very surprising. Okay, so yes, 0.45 is very surprising because none of them were in our sampling distribution. We didn't have any that were at 0.45 or less. They were all greater than that. Okay, Part C. Based on your answer to Part B, is there convincing evidence that the proportion of all students who did their homework was less than 60%? Yeah, so if we got a sample that's 45%, that's not going to happen just by chance. This is not going to be true. It has to be lower. So 60% is probably incorrect. Our sample indicates it's much less than 60%. And the last question, number 5 in the homework. A large pet store that specializes in tropical fish has several thousand guppies. The store claims that the length of its guppies are approximately normally distributed, okay, so you get that normal curve, with a mean of 5 centimeters and a standard deviation of a half centimeter, 0.5. You come to the store and buy 10 randomly selected guppies and find that their mean length of the 10 guppies is only 4.8. Identify the population parameter, etc. Okay, so our population are all the gummies. Our sample are just the 10 gummies that we bought. Our statistic is X bar. Okay, the mean of our 10 guppies was 4.8. And we want to find the parameter, which is mu, which is the true mean length of all the guppies. The true mean length of all the guppies. Okay, so Part B. Suppose the store's description of the lengths of gummies is true. The dot plot on the next page shows the distribution of 200 random samples of size 10. Okay, so if it's true, the mean really is 5. Okay, so we have a center here around 5. Okay, and so we took a sample of 10, we got 4.6. We took another sample of 10, we got 4.8. Took another sample of 4.8. Another sample was, so all these different points are a sample of 10. Okay, so Part B, would it be unusual to get a sample of one sample of 4.8 like we got? Is 4.8 that unusual? Okay, so 4.8 or less. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 out of the 200. Okay, 21 out of the 200 comes up to be a little over 10%. It's unusual, but it's not that unusual. Okay, so we wouldn't be able to say that no, it's not. When they say it's 5 centimeters, our sample was lower than what they say is true, but it could have just happened by chance, right? We might have just gotten that just by chance, so can't necessarily. So is there convincing evidence the mean is less than 5? No, we can't really say it's less than 5. Our sample could have been smaller just by the chance of the 10 guppies that we drew. It wasn't statistically significant.